In a previous video, I showed you the up-and-coming external intersection geometry. I mentioned that it has implications for my series of videos on the cut glass look. Since it has been said that anything worth doing is worth overdoing, I thought I'd have a look at that here. Start in the part workbench. As in a previous video, I already have a nice revolve with a join curve and a function sketch, all set to apply the macros and create the cut glass look. Only this time I'm in the weekly development version of FreeCAD. I put a link in the description if you want to download it and give it a try yourself. In this case I'm using revision number 39841. Get rid of the function sketch since we'll be using the external intersect geometry to set the radii. Open up the compound and go into Sketch 2. Select the external intersection tool and select the revolve. Now delete the radius constraint on the construction circle for the octagon. Select the construction circle and the external geometry and constrain them equal. And we hit the first snag. The intersection of the revolve appears in the form of a B-spline, and a B-spline does not have a radius. So delete that external geometry and close the sketch. We're not out of options, we still have the join curve. Hide the revolve away and reopen Sketch 002. This time bring in the join curve as external intersect geometry. It may be hiding behind the x-axis, so rotate the sketch a little to see it. That gives us this nice point. That makes sense, we're intersecting a line so we get a point. Select the construction circle and the point and apply point on object constraint. That's done it. Close the sketch. We still need the join curve for the same reason the function sketch needs it. The individual arcs of the sketch that we revolve do not cover the entire height of the revolve. Now do the same thing for Sketch 3. Don't worry that the external point isn't on the axis. As you might recall, this sketch has been rotated 22.5 degrees about the z-axis. But that doesn't affect the radius, so it's fine. You can see from the compound that we're on the right track. The next logical step is to select the compound and run the next row macro. But I can see this brings another problem. Sketch 002 and 003 now explicitly include the join curve as a dependency because we brought it in as external geometry. In turn, the join curve depends on the base sketch because that's what it was created from. The deep copy in the next row macro sees those dependencies and copies them. This is not what we want. For one thing, it's really going to clutter up the model tree. For another, having a bunch of independent copies of the revolved sketch and the join curve completely breaks the parametric design. Making a change to the shape of the revolve would require completely redoing everything. While the parametric nature of the model is already limited by having copies of the scaffold sketches, I'd like to not limit it further. I'll spare you the details of the various things I tried that failed and get to what worked. When we do a Control-C to make a copy, we get a nice dialog of everything that will be copied, giving us a chance to opt out of copying the join curve in the base sketch. It'd be really nice to be able to do that. It turns out we can. As I was digging through things, I noticed in the description of the copy object method that we can pass in an object or a sequence of objects to be copied. When you pass a sequence of objects, it's treated exactly as the results of the selection dialog. Just set deep copy to false so it only copies the things explicitly listed. There's a bug in the macros dialog in this weekly development release, so I'll just have to show you the new next row 2 macro in a text window. I'm sure the bug will be fixed soon. That's the nature of development weeklies. It may already be fixed by the time this video comes out. Without the deep copy, the dependencies of the compound will have to be resolved in the macro. We have a new function, getDeps, that expects the compound object as a parameter. I've written it in the form of a generator just because that's a little cleaner. First yield the compound itself. Then go through the compound's out list. If it finds a sketch, yield it. If it finds an extrusion, yield the extrusion and then yield the first item in the extrusion's out list. That will be the sketch the extrusion was based on. Now use a list comprehension to turn the iterator from getDeps into a simple list. Just hand that list to the copy object function, letting the deep copy boolean keep the default value of false. When copy object receives a sequence as its parameter, it returns a list containing the copies of the objects in order. Since the entire macro was already written based on finding everything in the out list of the copied compound object, just take the first item in the return list and assign it to O. The rest of the macro is exactly as before. Fortunately, the modified macro works just like the old one when you're using the set diameter macro. Now continue just like the previous video using the modified macro. I renamed it Next Row 2 to avoid confusing people following the original video. Move all those compounds into another compound. Select all of the extrusions out and fuse them. Put them in a lattice 2 polar array and cut them from the revolve. And there's our result. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.